How does the observer effect change experiments? Have you ever wondered how simply looking at something can change what it is? This is the essence of the observer effect in physics. It alters experiments by changing the behavior or state of the system being observed just through the act of observation itself. When scientists measure or observe something, especially at tiny scales like atoms or particles, the process can interfere with what is being measured. For instance, think about measuring the pressure in a tire. When you stick a gauge in, some air escapes, and the pressure you wanted to measure changes. This everyday example shows how observation can disturb a system. In the world of quantum physics, the observer effect becomes even stranger. Quantum particles, like electrons or photons, act like waves and can exist in multiple states at once. This is known as superposition. The famous double-slit experiment illustrates this oddity. When particles pass through two slits without being observed, they create an interference pattern on a screen, acting like waves going through both slits at the same time. However, if an observer tries to measure which slit the particle goes through, the interference pattern disappears. The particles behave like tiny bullets going through only one slit. This means the act of measuring collapses the particle's wave-like behavior into a definite state, changing the outcome of the experiment. This collapse of the wave function shows that the observer effect in quantum mechanics is not just about physical disturbance. It is also about how measurement forces the system to choose a state. This is why quantum experiments often yield different results based on whether or not they are observed. From a weird science perspective, this leads to quirky scenarios like Schrodinger's cat thought experiment. In this scenario, a cat in a box is both alive and dead until someone opens the box and observes it. The observer effect highlights how reality at the quantum level seems to depend on observation, challenging our everyday ideas of objective reality. Some interpretations even suggest that consciousness might influence physical reality. However, mainstream physics clarifies that it is the interaction with measuring devices, not necessarily a conscious mind, that causes the change. This idea fuels many strange theories about the role of mind and observation in the universe. Practically, the observer effect means scientists must design experiments carefully to minimize disturbance. In quantum computing and quantum cryptography, for example, managing the observer effect is crucial. Measuring quantum bits can alter their state and affect computation or security. In other fields, like biology or psychology, the observer effect explains why animals or people behave differently when they know they are being watched. This can complicate experiments and observations. The observer effect changes experiments by making the very act of observation an active part of the system's behavior. Especially in quantum physics, it can switch particles from wave-like to particle-like states, producing strange and unexpected results that challenge classical ideas of measurement and reality.